Hello everyone, my name is Dmitry and today I'm going to tell you about universal inputs of Galileosky devices. Universal inputs of trackers are truly universal. They can help you measure voltage and frequency, determine pulse number per second and more. But first thing first. The range of measuring signals is as follows. Voltage from 0 to 33 volts. Frequency up to 4 kHz. Pulses up to 4000 per second. So, the first mode is the average value. In this mode, the device measures the value of the analog signal at the input. The result of the measurement is displayed on the device tab. However, this is only the small part of the mode's features. We can treat the signal input voltage as an analog signal or as the discrete state, logical 0 or logical 1. For example, if a sensor with the voltage output is connected to the input, it is the voltage at the input that you should pay attention to. However, in many cases, you just need to know if there is a voltage at the input or not. The typical example is a button or the door opening sensor. In this case, we need to set the logical 0 and logical 1 voltage levels. For this, you need discrete signal range scale. Red zone is the zone of the logical 0. Green is the zone of the logical 1. The yellow zone is an undefined state. In reality, if the voltage enters the yellow zone, the logical level remains as it was before. For example, if the voltage was in the logical 0 zone and for some reason there was a small jump to the yellow zone, the logical state of the input will remain 0. The logical state of the input will only change when the input voltage reaches the green zone. You can change the zone boundaries in the red and green zones simply by moving the markers with the mouse. Or you can set the zone boundaries in millivolts in the fields under the scale. The filter length parameter in this input mode allows you to average the measured voltage value. The tracker pulls the input 20,000 times per second, so to average the value in 1 second, the filter length should be 20,000, and for 3 seconds, the filter length will be 60,000. Also, the input pull-up to the plus signal function is available for 7X devices. This feature is extremely useful if you want to connect, for example, the button to the input. The thing is that without a pull-up, you have to pull an extra wire with the plus signal, which is not always convenient. If we activate the input pull-up feature, the device input will have a constant voltage of about 2 volts. Now we can use the button that connects the input not to the plus of the power, but to the car body. When the button is pressed, the voltage on the input will be 0, and if it is not pressed, it will be about 2 volts. This approach makes the installation process much easier because the mass is available anyway in the vehicle and there is no need to pull additional long wire. Now we just need to fix the levels of logical signal and set new parameters. Let's consider the pressed button means a logical 1 and the released button means logical 0. Set the boundaries of the red zone from 1500 mV to 33,000 mV and the logical 1 zone from 0 to 1000 mV. Do not forget to apply changes. Please note that when you change the logical state of any of device inputs, the device automatically records additional point. Thanks to this, you always know where and when the state of the input has changed. If you work with universal inputs as with the set of logical state, you don't need to send the real voltage from inputs to the monitoring software. It is enough to add the status of inputs parameter to the main packet on the protocol tab. And you can also remove inputs values from the protocol. This will allow you to slightly reduce the size of the main packet. By replacing the inputs values with the single status of inputs tag, I reduce the size of the main packet by 12 bytes while using 6 inputs of the device. It may not seem like a lot, but considering how many points go to the software even in one day, the savings are noticeable. Also, reducing the size of the single point allows us to save more points in the device memory in case it is out of GSM coverage area. Such features as the ignition signal and the emergency button are working with logical state of device inputs. Let's take a look at these features. The tracking device can detect if the vehicle is moving in 3 ways: the ignition signal, the power supply voltage level, or built-in accelerometer readings. The ignition signal has the highest priority. This means that if the device settings were made incorrectly, you will always see your vehicle in the same place in the monitoring software, even if the car is actually moving. Let's see how to set ignition signal. On the track tab, we can select one of the device inputs as the ignition input. Let it be input 2. Now we need to go back to the inputs-outputs tab and set the correct limits of the discrete signal on this input. The tracker considers that the ignition is on if there is a logical 1 on the corresponding input. Let's suppose that the device is installed in the car, and when the ignition is on, the input voltage is exactly more than 12 volts. In this case, we set the red zone from 0 volts to 7 volts and the green zone from 9 volts to 33 volts. This completes the ignition input settings. Please do not forget to apply changes. The emergency button is configured in a similar way. Let's go to the signaling settings tab and assume that we connected the input 0 to the emergency button. In the input settings, select Enables Alarm Mode. The logic of the panic button is the same as that of the ignition signal. That is, when the input logical state is 1, the alarm is triggered. So, in this case too, it is extremely important for us to set correct logic signal levels on the selected input. As you remember, we have already configured the input to trigger at the 0 voltage level on the input. It means that we must connect the panic button so that it connects the device input to the mass of the vehicle. It will be the logical 1 from the perspective of the device. We can also set the delay after the input is triggered before the alarm is activated. This allows us to avoid false alarms when the button is pressed accidentally. Let's specify a delay after triggering as 3 seconds. Now, in order to trigger the emergency button, it must be held for more than 3 seconds. This will prevent the false alarms. The signaling settings tab allows us to make much more useful settings. I recommend checking our user manuals for more details. Today we've looked at one of the available modes of universal inputs in detail. We will talk about other modes in the next video. Dmitry was with you. See you later.